In this video, I'll show you how to solve the ALEKS problem called Finding a Molecular Formula for Molar Mass and Elemental Analysis of Binary Compounds. This problem is asking us to come up with the molecular formula for a compound. We're being provided with the mass percent of the elements in the compound, and we're also being provided with the molar mass. So I'm going to show you what I think is a pretty straightforward way to solve these problems. What we're going to do is assume that we have 100 grams, a 100 gram sample of this particular compound. If we have a 100 gram sample of this compound, we know from the data provided to us that 20.24% of that 100 grams is going to be due to the aluminum atoms. And because I chose 100 grams, which is a really easy number, in this 100 gram sample, I'm going to have 20.24 grams of aluminum. And again, in my imaginary 100 gram sample, due to the data provided to us, I know that 79.76% of the 100 gram sample is going to be due to the presence of chlorine atoms. So that means I'm going to have a total of 79.76 grams of chlorine. And when we're coming up with a molecular formula, our job is to come up with the subscripts in the formula. And these subscripts represent a mole-to-mole ratio of the elements in the compound. So the moles of aluminum to the moles of chlorine in this particular case. Right now, what I have is a mass-to-mass ratio. I have the mass ratio of aluminum to chlorine. What I need to do is just simply convert these masses into moles so that I can figure out what these subscripts are. So my next step here is to just do a couple of gram to mole conversions. I'm going to begin by converting aluminum from grams into moles, and we do that using the atomic mass of the elements. So for aluminum, the atomic mass is 26.982. I'm just going to round it to 27. That means 1 mole of aluminum is 27 grams. We're going to work the math out on that in just a second. We're going to do the same thing for chlorine. We're going to convert chlorine from grams into moles using its atomic mass, 35.453. I'm just going to round that to 35. And take a look at how these units are going to cancel out. Actually left the atoms off the top there. So let's get our calculator and we'll work the math out on this. For the top one, 20.24 divided by 27 is 0.7. I'm just going to round that to 0.75 moles of aluminum. And for the chlorine, 79.76 divided by 35 is 2.28 moles of chlorine. So again, let's think about what we're doing. We're trying to come up with the molecular formula, which is the mole-to-mole ratio of aluminum to chlorine. We started off with a mass-to-mass ratio. Now we have a mole-to-mole ratio. It's not quite done because that mole-to-mole ratio is not in conventional format. So let me just kind of write down what we've done so far. We've determined that the ratio is aluminum 0.75, chlorine 0.228. And you know from experience that these numbers are typically whole numbers like 1 or 2 or 5. They're not decimals. Don't be tempted to round to like the nearest whole number, like do this kind of a thing. Don't be tempted to do that. That's definitely the wrong way to go about doing it. These numbers are not close enough to 1 or 2 for us to feel comfortable rounding. What we need to do is maintain the ratio of 0.75 to 2.28, but also convert these into whole numbers. So by that, what I mean is that I want to maintain this 0.75 to 2.28 ratio. I don't want to interfere with that, but I want to change these into whole numbers. And the way that we're going to do that is to pick the smaller of these two numbers, which for me is 0.75, and we're going to divide both of the numbers by that little one. So you're going to pick your smallest number, and you're going to divide both of them by the smallest number. The aluminum, 0.75 divided by 0.75, is going to become 1. I'll leave the subscript there for a second. Chlorine, 2.28 divided by 0.75. That works out to be almost exactly 3. So this formula becomes ALCl3, which looks much nicer than in these decimal places. Now, don't assume that we're automatically done. The problem says that the molecule has a molar mass of 266.64. We need to double check to make sure that this thing has a molar mass of 266.64. So we're going to add up the molar mass of this compound 1 aluminum, I've got the molecular or the atomic weights up here. We're going to use those. 1 aluminum is 27, and we have 3 of those chlorines, which gives us a total mass of 132. That is not 132 grams per mole. That is not the molar mass that's provided to us in the problem. The molar mass in the problem was 266.64 grams per mole. So what we need to do is modify these subscripts again while maintaining the ratio. I'm going to put the 1 back. We're going to want that 1 back. We're going to modify these subscripts, maintaining the 1:3 ratio to get the mass up to 266. So what we're going to do in this strategy this time is we're going to multiply both of these subscripts by 2. Now this math that we're doing up here, dividing it doesn't change the ratio. Multiplying it by a number doesn't change the ratio. When we multiply our subscripts, we get Al2, Cl6, and let's calculate the molar mass of that. It's basically just going to be twice what I had come up with before, which is 264 grams per mole. Now that is not perfect. That's not exactly what ALEKS provided, but keep in mind that up here in this step and also in this calculation and this calculation as well, I really rounded these atomic masses. And if I went back to the periodic table and didn't round my atomic masses, I'm completely confident that I would end up with the exact same number as what I got in ALEKS. So it is not a great idea to round, especially with ALEKS problems. My answer is Al2, Cl6.